In this example, we're going to look at dividing whole numbers by fractions. Use the diagrams given to represent the division problem and find the quotient. So let's read our first problem. Tia made 3 cakes for her guests. If each guest receives 1/5 of a cake, here's our question, how many guests can Tia serve? So we're given a picture and we're going to start. Each rectangle is going to represent a unit, which is 1 cake, and we have 3 cakes in total. So each guest receives 1/5 of a cake. We're going to cut each cake into 5 equal pieces, which takes 4 cuts. And imagine they're all the same size. So once we cut them into 5 pieces, each piece is size 1/5. Okay. So now to see how many guests she can serve or how many servings we have, we can count each of these 1/5. So how many copies of this 1/5 do we have here? So here there's 1, 2, 3, 4, 5. Continuing on, 6, 7, 8, 9, 10 guests or copies, 11, 12, 13, 14, 15. So in copies of language, what we just figured out is how many copies of 1/5 are in 3? Okay. Symbolically, we were taking the amount 3 and we wanted to see how many pieces or copies of size 1/5 there were. So when we have how many copies, remember that's a division problem, of the 1/5 are in 3. The 3 is the dividend. We're putting it into pieces of size 1/5. Okay. Now we haven't formally learned an algorithm for this, but I want you to think about what we did. Okay. We took the 3 and we cut the 3, each of the 3 into 5 equal pieces, giving us 3 times 5 pieces, which is 15, and in the context of this problem, we would say 15 guests can be served. Now, I absolutely want you to start looking for patterns. We're going to be looking for patterns in dividing with fractions for the next video, or 2 or 3. So you may notice, well, we had 3 divided by fifths equals 3 times 5. Notice division changed to multiplication, and we ended up multiplying these numbers. Now that's not the whole story, but that's the start of a story. So start looking at patterns like that to make sense of these problems. Let's look at the next one. Elaine ran 6 miles this month. If she ran 3/5 of a mile every day she ran, we want to find out how many days did Elaine run. So first we have our number line. Okay, it's starting at 0, it ends labeled at 6, so it's set up for this 6 miles. So this is representing the miles Elaine has run or ran this month. I think we say ran, has ran this month. Okay, so every time she runs, the total amount she has ran this month increases. So we're going to write all of those values out. So notice I already have, this is partition, there's 1, 2, 3, 4 cut marks, so 5 equal intervals here. So they're already cut into fifths. So we're going to start at 0. So this would be when she has run 0 days, she has run 0 miles. And then 1, 2, 3 fifths. This is how far she's run in total at the end of the first day. 1, 2, 3. After she's run 2 days, she's run 3/5 plus 3/5, which is 6/5, or 1 1/5. Now we're going to keep going. 1, 2, 3, 4. I'm sorry, 1, 2, 3 is 3 days. 1, 2, 3 more is 4 days. Here's 5 days of running, 6 days. So I'm just partitioning this into all these groups of length 3/5 and counting how many there are. 1, 2, 3, 9, 1, 2, 3, 10. So based on our diagram, I can say if Elaine ran 6 miles this month, there are 10 copies of 3/5 in 6, so she must have ran a total of 10 days. So let's write this in copies of language like we just talked about. So we were asked or wanted to find how many copies of 3/5 are in 6. Okay. So when we have this how many copies of, that's a division problem. This is our dividend, what we're dividing. This is our divisor, what we're partitioning this into pieces of. So we had 6 divided by 3/5. Okay, and we know the result is 10, but let's look at this image a little bit. Now notice this was 6, but each one of these is 1/5. So we actually had 30/5 here. So 6 equals, we'll just write this here, equals 30/5. Okay. And then if we had 30/5 and we counted how many 3/5 there were, we found that there was 10 of them. Okay. So 6 equals 30/5 over 3/5. And notice, since these have pieces of the same size, they're both in fifths, 30 divided by 3 is 10. So we have 10 days. Okay. Now, here's just one other way to think about it. The more ways you have to think of it, the better you can make sense of it. We could also say we took the 6, okay, and we broke the 6, each of the individual units, into 5 pieces. So I can think of multiplying by 5. That gave us our 30 pieces. And then we counted in 3s. So since we took the 30 and grouped into 3s, that's dividing by 3. Now, if we multiply across, that's 30 over 3, which is 10 days. Okay, so both of these are expressing or showing the same idea, the same concept, but it's different ways to think about it. And again, the biggest thing you'll probably face when you have problems like this is you'll start thinking, oh, do I multiply this 3/5 times 6? Do I divide? How do I know which I'm doing? Okay, and what you really need to do is be able to find a mental picture and be able to make a copies of statement that helps you think, are you finding the number of copies in something, or are you taking a number of copies of something? Okay, and I know that language is a little bit close, which is why you really have to think about it. Making these diagrams and using this different language will definitely help.